Okay, so we're on 43. I want to get as far as number 49. 49 is going to be the last one we do. It's going to stop at 47. 49 is a really, really, really quick, easy one. Okay, so we'll go as far as number 50 on the assignment. You can cross off 51 through 57. Okay.
How many did you say cross off? I thought you said the last one we were doing was 47.
I was, then I said 49. 49 is easy. 49 and 50 are they're very, very quick, easy ones. Okay, so let's look at number 43. 43, this is on worksheet 1-6. Okay, so we have x plus 1 over 2x minus 3. Okay, so first off, this might be the first problem that's like this. I think it is pretty much. We don't have 0 on one side, so we got to have 0 on one side, so we got to subtract off that 2. So minus 2 and minus 2, so we have x plus 1 over 2x minus 3 minus 2. I'm going to make it 2 over 1 is bigger than 0. Okay? So, we got to have a common denominator. When we subtract fractions, we need a common denominator. Common denominator of 2x minus 3 and 1 is 2x minus 3. So we're going to times this by 2x minus 3 times the top by 2x minus 3. Okay, so if I do that, we have x plus 1 over 2x minus 3 minus 2 times 2x minus 3 is 4x minus 6. It's bigger than 0. And be careful when you subtract here. We're going to take x minus 4x, that's a negative 3x. If you're going to make a mistake, here it is. Some students say, well, 1 minus 6 is negative 5. That's not minus 6, it's 1 minus minus 6. Minus minus is plus plus, it's really 7, or 2x minus 3. And that doesn't factor. Okay, that doesn't factor at all. So, our critical values, remember our critical values are what makes the top 0 or the bottom 0. So our critical value on top would be the opposite of this over this, so negative 7 over negative 3. Whoops. And the opposite of this over this, critical value on bottom is 3 over 2. And I'm going to make negative 7 over 3 into positive 7 over 3. Negative over negative is a positive. Okay, so those are our two critical values. Okay. Now we're not going to include our endpoints here because there's no equal sign. Remember, we talked about this last week. If you don't have an equal sign under it, you don't include the endpoints. If you do have an equal sign under it, you might include the endpoints. It depends. Make sure we put these in the right spots. If you're not sure where these go, you should be able to tell that 3 goes into 7 twice with something left over. 2 goes into 3 once, so 3 halves is smaller. Okay? 3 halves is 1 1/2. 7 thirds is 2 1/3. So make sure we put them in the right spots. And since these are both raised to an odd power, it's going to alternate every time. It's not going to bounce. Okay. If I was to plug in a number to the right of 7 thirds, like 100, if I plugged in 100 or a million or a trillion, or it doesn't matter, a big number. Negative 3 times a big number is a big negative number. A big negative number plus 7 is still negative. If I plug in a big number here, 2 times a big number is a huge number. A huge number minus 3 is a positive. A negative over a positive is a negative. And they're going to flip-flop, so negative, positive, negative. They don't bounce anywhere. We're interested in where this thing is bigger than 0, so where it's positive. So we don't include the endpoints, so we just put 3 halves, comma 7 thirds, parentheses around each. Anything between 3 halves and 7 thirds will work. Not including 3 halves or 7 thirds. Okay, number 40, I wouldn't write down number 45 yet. I wouldn't do it, okay? I'm going to do it. I wouldn't if I was you guys. It's going to be, I'll save you a little bit of work here, okay? And what I mean is, I'll write the problem down, just watch. We have 1 over x minus 2 is bigger than or equal to 3 over x plus 1. Okay, we got to have 0 on one side, and it doesn't matter which side's 0. So I need to get rid of this 3 over x plus 1. So here's what I would write, okay? Again, I wouldn't write any of this yet. I'm going to subtract 3 over x plus 1. Subtract 3 over x plus 1. So rather than write all this out, write this, subtract that is bigger than 0. Just write this over here but make it negative. So 1 over x minus 2 minus 3 over x plus 1 is bigger than or equal to 0. That's what I would write first. Okay? So again, in a nutshell, if you didn't catch that, I wrote down the original problem, the start of the original problem. I wrote this down, then I wrote this on the same side, but I wrote the opposite of it. And when you move things to the other side, they turn opposite. That way we have 0 on one side. We need a common denominator. I don't think I've talked to you guys about this. Maybe not at all. I know not this year, I don't think. A very simple way of getting a common denominator, if I gave you denominators of 37 and 48, how would I find a common denominator of 37 and 48? Anybody know? It's whatever 37 times 48 is. I don't know what that is, but it is. Okay, that's a common denominator. Okay. Now, if I give you denominators of 2 and 4, a common denominator is 8. 2 times 4. It's not necessarily the least common denominator, though. Okay. So why do I bring that up? If your denominators are x minus 2 and x plus 1, your common denominator is x minus 2 times x plus 1. So I'm drawing two fraction bars with x minus 2, x plus 1's on bottom. That is our common denominator. And don't multiply it out. We like it in factored form. When it's in factored form, it's a lot easier to find the critical values. Okay? Let's look at our first fraction. We have x minus 2 here. We have x minus 2, x plus 1. So I got to times the top by x plus 1. 1 times x plus 1 is x plus 1. Do the same thing here. Let's turn an x plus 1 into an x minus 2, x plus 1. We times by x minus 2. 3 times x minus 2 is 3x minus 6. Now, I'm just curious, okay? Could we cross off this x plus 1 and this x plus 1? Could we?
No.
We could. Well, be careful. Now, you might be thinking, well, it's separated by pluses. Is that why you said no? You got to be careful here, okay? I can't cross off just this one and just this one, but x plus 1 and x, I see all of x plus 1 and all of x plus 1. Those aren't separated. They're separated by parentheses. I could do that. I definitely could do that. But I don't want to do that. And here's why. If I do that, if I cross those off, I'd have 1 over x minus 2. Don't write this down. You can do that, but it's not a good idea, though, because why? When you subtract fractions, what do you need? And do we have a common denominator? No, we don't, but back here, we do. Okay? So, let's clean this up. We have x minus 3x, that's a negative 2x. 1 minus minus 6 is 7, plus 6, over x minus 2, x plus 1. The top doesn't factor. Okay? So our critical values, there's 3 of them. Okay, we take the opposite of this over this, negative 7 over negative 2, positive 2 and negative 1. I'm going to make negative 7 over negative 2 into positive 7 over positive 2. Okay, none of these are raised to an even power, so it's going to flip-flop every single time. It's not going to balance ever. Put them in the right spots. Negative 1 is the smallest number. 2 is the next smallest, 7 halves is 3 1/2, so that's, oops, not 7 thirds. 7 halves is the biggest number, that's 3 1/2. If we were to plug in a number like 1,000, okay? 1,000, negative 2 times 1,000 plus 7, it's gonna be a negative number. If I plug in 1,000 minus 2, that's a positive. 1,000 plus 1, that's a positive. A positive times a positive is a positive. A negative over a positive, it's a negative. And we said it's going to flip-flop, so negative, positive, negative, positive. We're interested in when this thing is bigger than or equal to 0. We're interested where it's positive. We might include the endpoints. We might. There's an equal sign there. We might. We might include them, okay? So we want to know where it's positive. So it's positive here, it's positive here. So here, the smallest number, I say that kind of quote-unquote number, is negative infinity. Just so you understand, negative infinity, that's not a number. Infinity is not a number, it's a concept, okay? So quote-unquote smallest number is negative infinity. So negative 1, we don't include negative infinity. Again, we have an equal sign here. Do we get to include negative 1? No. Because if we did, we would get 0 on bottom. Or between 2 and 7 halves. Between 2 and 7 halves. Do we get to include 2? No. We get 0 on bottom. Do I get to include 7 halves? Yeah, because you get 0 on top, and that's okay. So we put a bracket around 7 halves. So we're saying everything to the left of negative 1, not including negative 1, or between 2 and 7 halves, including 7/2, but not including 2. Okay, I mean, we're basically doing the same problem over and over and over, for the most part. Same process. Again, number 47, I would not write down number 47. I would write down the beginning of 47. I would write down x over 3x minus 5. But I would write down what's on the right next to it, but don't put down 2 over x minus 1, put minus 2 over x minus 1. Again, we're doing that, so we have 0 on one side. And we need a common denominator. Common denominator of 3x minus 5 and x minus 1 is 3x minus 5 times x minus 1. Okay, to turn 3x minus 5 into 3x minus 5 x minus 1, we times by x minus 1. X times x minus 1 is x squared minus x. To turn x minus 1 into 3x minus 5 x minus 1, we times by 3x minus 5. 2 times 3x minus 5 is 6x minus 10. Okay. Then we need to simplify. So we have x squared, negative x minus 6 more x's is negative 7x. And be careful here. You might be tempted to say, oh, we're left with negative 10. Not negative 10, negative 10, which is positive 10. I would hope this one, when you look at it, you could be able to tell very quickly whether it factors or not. And when you see 10 and 7, I mean, really, there should be 2 numbers popping in your head when you see a 10 and a 7. What would they be?
5 and 2.
What's so special about 5 and 2? Times 10, add to 7. So x minus 2, x minus 5, or 3x minus 5, x minus 1. Nothing cancels. There are 4 critical values. 2, 5, positive 5/3, and 1. Okay? It's not going to bounce at any of them. It's going to cross over every time. Let's put them in the right spots. Smallest number here is 1. 5/3 is a little more than 1, so 5/3 is next, then 2, then 5. Make sure you put them in the right spots and then underline. This is going to flip-flop every single time. If I was to plug in 1,000, 1,000 minus 2 is positive, 1,000 minus 5 is positive, 3 times 1,000 minus 5 is positive, 1,000 minus 1 is positive. They're all positive. Everything's positive, so it's going to be positive, negative, positive, negative, positive. And we're interested in when it's